Good afternoon, DevSecOps enthusiasts. Welcome to the second part of our three-part series on Red Hat OpenShift on DevSecOps and containerization. Thank you if you joined us last week. We started off our session with OpenShift 101. We discussed why to use containers and what specifically are the advantages of OpenShift. We discussed the need for Kubernetes to ease the management of those containers and how OpenShift goes further than Kubernetes to enable enterprise environments on day one. We discussed value-added services to the platform, application, data, and developer services, and how hybrid clouds are an important concept to be utilized. Finally, we provided you some additional resources to improve your likelihood of success during the Open Hat containerization solution implementation. That recording is available on the Government CIO Media website, and we're very happy to have you join us today for the second part of the series that's focused on operations, a day in the life of operations. At this time, I'd like to introduce John Keem back to the stage to take us through the presentation for today, after which we'll have a questions and answers period and some discussion. Thanks.
Hey, Mark. Thanks for having me back. Had a great time last time and hope it was a fun, informative session for you all. And if you haven't seen it, go check it out. But today I'm really excited to talk to you about day in the life of operations. You know, the DevSecOps idea, you know, one of the key parts of that is the operations team. Often I like to say the unsung heroes. They keep everything running smooth, and if everything works the way it should, then, you know, they never get the accolades. But, you know, today we're really going to focus in on kind of what their day looked like and how OpenShift can alleviate and make and simplify a lot of the things that they do every day. So once again, my name is John Keem. I'm a hybrid cloud solutions architect here at Red Hat. And yeah, I'm really excited, and we don't have a lot of time. So let's get rolling here. Got a lot of stuff to talk to you about. So today there's a lot of things on here, but don't worry, we're going to get through pretty quickly here. We're going to talk about, again, the high level things that an operations person would do. And we're going to go through each of them and kind of see, again, how OpenShift makes all that easier. So like I said, an operator is not only critical to IT, but the entire organization itself. Systems being down could be millions of dollars in lost revenue and or lost trust from your users. It's operations responsibility to ensure that all of the systems run smoothly, are up to date, are secure. I mean, it really is a daunting task. And when done right, like I said, thankless job. So what do I mean when I say traditional operations? So we talk about traditional operations versus the new world with OpenShift. Traditional operations. We talked a bit about this in the last session, but let's do a quick recap. So typically within an organization, we have highly functional teams that all focus on their particular roles and responsibilities. Traditionally, these teams don't, you know, they don't communicate, collaborate as best or as well as they could. Let's take a very specific example to see what I mean. So this is actually a story from my past. I'm not going to say any names, but let me go through this. So say your organization has a major delivery, let's say by the end of the week. So trying to avoid weekend work, the developers put in long hours. And at this point, as an operations person, you're a little worried that the deadline is quickly approaching. They're not done yet, and they're not leaving you a lot of time to figure out how to deploy their app or write the proper procedures and policies around it. So you ask for some guidance, but you're brushed off as the development team is way too worried and concerned about getting it in on time, getting the app done. This is kind of disconcerting, but you've got 100 other fires to focus on, so you just go off and work on this. Then come 4:45 p.m. on Friday, the last developer marks their ticket as done, the dev team tags their release, and they leave for an impromptu happy hour just to celebrate their heroic, monumental achievement. And on the way out, the development team lead stops by your desk and says, oh yeah, by the way, can you deploy tag version 34 for me, 3400? Thanks, that'd be great. And as you hear the last developer leave, you look at the code and you realize that they have nothing in the way of documentation, let alone any idea how to build or deploy their application. You send out an email, but you know that they're long gone, and you're on the hook for this being deployed on Monday. And it looks like it's going to be a long night, if not a long weekend. So if this story sounds even remotely familiar to you, let me tell you, you're not alone. I know this happens because I used to be a developer and I did this to my poor ops team. I took it for granted that they would just figure it out and come through on Monday, which they always did. But there really has to be a better way, right? And so that's really what DevOps, DevSecOps is all about. I'm going to read from you the Red Hat definition, mainly because I really like it a lot. So DevSecOps provides or describes approaches to speeding up the processes by which an idea, like a new software feature, a request for enhancement, or a bug fix, goes from development to deployment in a production environment where it can provide value to the user. These approaches require that development teams and operations teams communicate frequently and approach their work with empathy for their teammates. So I really love that. My favorite part of that quote is the empathy part. Really trying to understand the world through your teammates' eyes and walk a day in their shoes. Now, with compliance being as important as it is in the government, adding security early in the process is critical towards being able to do really anything. And this is why that portmanteau of DevOps most recently has been changed to DevSecOps to really bring into focus the importance of folding security scanning and auditing and all of the report generation into the development process early. For instance, a violation of security policies set around coding standards or third-party vendor libraries should instantly fail to build and communicate what needs to be fixed. So what does DevSecOps really mean? Well, it means the ability to deliver more frequent code changes and more dynamic infrastructure faster. Traditional management strategies can't keep up with this demand. So we're going to need to change a few things in order to give you that edge. Okay, so the main tangible benefits from development, operations, and security teams working together is smaller, more frequent releases. This puts a lot of stress on operations. Being able to keep up means working smarter, not harder. This is where automation comes into play, and is one of the key ideas of DevSecOps. Here we go about how we go about exactly achieving that is a different story. But today, I wanted to show how OpenShift is the platform that enables and fosters that DevSecOps culture and best practices. Okay, so the OpenShift advantage. We talked a little bit about this last time, but today we're going to look again in depth, in detail, on how it particularly relates to the operations side of the house. So this is also a recap from last time, but I like this drawing. It really distills down all of the value-added services and all the extra things that OpenShift adds on top of that Kubernetes layer. So we'll do a quick recap here. Starting at the bottom, OpenShift runs almost anywhere. Physical, virtual machines, on-prem, in the cloud, even on smaller footprints on the edge. And above that is that Kubernetes layer, which is that container orchestration layer that allows you to schedule and run containers and really embrace, and be able to manage containers better. Kubernetes is the kind of like the platform these days, and for good reason. It offers a lot of flexibility. But that flexibility also means that you have to make a lot of choices. And you have to make a lot of decisions of what exact implementations of things you want to use, and then how to go about doing that, putting processes and procedures around that. That's more work. And so OpenShift adds a nice layer on top to make that easy. So for instance, over-the-air updates, being able to update the underlying Kubernetes. We make it super easy with as easy as a single button click. Or how do you add persistent storage? What's your strategy there? Again, OpenShift makes things like that easy. Or an image registry right out of the box where you can start putting containers into, images into. Really, really nice. So on top of those cluster services, we add 4 other additional types of services, each with its own kind of mission or goal that it tries to achieve. And we're going to go through those briefly here. So we have the platform services, which is really meant to extend the OpenShift platform, where now you're not just thinking about running containers, you're thinking about the architecture that you're going to use when running those containers. Maybe you want to use a service mesh with a bunch of microservices. Yeah, you can easily pull in the capabilities to be able to allow that functionality to happen. Or you want to be able to run serverless, functions as a service type of paradigms. yeah, we allow that easily to happen as well on day one. Or you want to have build pipeline, CI/CD tooling. Yes, all things that are easily to be able to add with almost a single button click to add those capabilities onto the platform. Okay, application services, the next bit. So you're thinking about the applications and the workloads that are actually running in OpenShift. Well, we also add support for the runtimes underneath it. If you're using OpenJDK, using Spring Boot, we support those so that if there's any problems with the underlying framework or language runtime itself, we support it, and Red Hat will make sure it works and then make sure it's fixed if it doesn't work. Data services, data is king. If data is ephemeral by default for containers, so being able to store it persistently, we're going to get into that in a bit, getting a little teaser here, but data is super important, and we add data services inside of OpenShift, like a distributed caching layer or AI ML type pipelines. And last, developer services. The developer has certain tooling that they can pull in and be able to use to make them more productive. We have CLIs for OpenShift developer-centric workflows, and we have things like code-ready workspaces, which is an IDE right inside the cloud that they can start being productive on day one. And on top of all of that, we have the advanced cluster management layer that enables all the management of all your OpenShift clusters from one single place. Okay, so that was a recap of what OpenShift is. Again, Kubernetes with a bunch of stuff added on top. Now, all of the features that come with OpenShift mean an enterprise-ready platform on day one. Already hardened, already secured, already configured, all to make your life easier as an operations person. So for a human operator using OpenShift, there are specific, distinct features built right onto the platform to make that everyday operation tasks even easier and painless. And today we're going to be talking about these. Okay, so the first starting from here, there's a quick list of the most notable and arguably most powerful features. Like I said, we're going to go into detail on a few of these topics, but at a high level, we have the first is the installation. You got to get OpenShift installed. We try to make it as easy and as painless as possible with a fully automated installation process. Next, we have operators, and we're going to dig into what operators are, but operators that enable easier expansion of the OpenShift capabilities and easier management of OpenShift. And then we have simplified operations, easier updating of the OpenShift cluster itself with over-the-air updates that, like I said, become as easy as a single button click. And the ability to manage multiple OpenShift clusters in a variety of cloud and on-prem environments at the same time. Okay, let's talk about that first task that a human operator would typically have to perform, the installation. Included with OpenShift is the OpenShift installer that works in a variety of places, including all the big cloud providers, bare metal, and VMs. Now, new in OpenShift 4.6, OpenShift installers also support AWS GovCloud and Microsoft Azure Government. So that installer that comes with OpenShift has two modes. That first mode, these are the red boxes here, that first mode is that full stack automation installation. That's where first the entire infrastructure is created for you, and then OpenShift is installed on top. And this is actually the preferred method of installation, as it encapsulates all of Red Hat's best practices and recommendations in the installation. Basically, you kick off a script, you wait 30 minutes to an hour, and you come back and you have a fully installed cluster. If, however, you have existing infrastructure, or you have limitations on how that infrastructure must be configured in order to maybe be compliant or something with your organization's policies, then you could use that second mode of installation. As you can probably guess, it's more manual, but opens up a vast amount of configurability, as now you are kind of acting as the script in a lot of ways, where you're standing up that infrastructure yourself. And lastly, the blue boxes, we offer the hosted options, which I'm gonna see a bit in detail here. So hosted options, maybe you just wanna run OpenShift and you don't wanna even deal with installation. Okay, and you don't wanna deal with management. Okay, no problem, we got that. And that's that managed offering. So we offer OpenShift in Microsoft Cloud called Arrow, that's the blue one there. And AWS, it's the orangey one, called Rosa, and in IBM Cloud. The advantage here is that Red Hat engineers work with Azure, AWS, and IBM engineers respectively. And the experience is nice and easy. It's all integrated, and you get a single bill from the cloud provider that just includes everything. If, however, you didn't really care about the underlying cloud provider, you could opt for OpenShift Dedicated, where Red Hat engineers will provision the infrastructure for you. And instead of a cloud provider, you get a single bill from Red Hat. Now, coming soon, I bring this up because coming soon is a hosted OpenShift option in Microsoft Azure Government. And sometime down the road after that will be AWS GovCloud. Okay, so let's say you've got the cluster installed. Great. Now, as you start to use it, there's security vulnerabilities that come out because that's the nature of software, and maybe there's an upgrade with new capabilities. How do you get that in and working in your cluster? Well, our goal was not just to simplify the installation, but also make that upgrading and patching even easier and fully automated using an over-the-air update model. So first, the OpenShift cluster figures out whether or not a new update exists, and if so, presents to the human operator an indication that that update is available. And the human operator can choose to apply the update, at which point the OpenShift system will determine the proper procedures in order to update without any impact or downtime to your workload. And this even works in a disconnected environment. As you probably guessed, the process is a bit more involved, but overall, try to keep it super simple. The idea here is we want to make upgrading the OpenShift platform as easy as updating your mobile phone. Okay, so that's the upgrade and patching process. Now, what about deployment? We've got workloads, we've got applications that we need to deploy onto OpenShift. What does that look like? So deployment's an interesting topic because there are so many tools and approaches to get an application to production. So to me, when I say that, when I think about that, on its face really screams to me pipelines, pipelines, pipelines. And like a physical pipeline carrying water, you can think of a software pipeline carrying code from developers out to production to service your customers. And like a physical pipeline, you might have various filters and stages. So too does a software pipeline. Now, this topic is really, really large, and I don't have time for today. So I'm going to defer this conversation until the next session when I'll be talking about how OpenShift benefits the developer world and day. Today, instead, I'll be talking about the actual tools and that might be used in the steps to actually get that application to production. So kind of like the last mile where it actually deploys it. Okay, so the very first that I want to talk about is the very popular Helm tool. So if you've used Kubernetes, you've probably run into this technology or probably used it yourself. But if you haven't, that's okay. I'm going to talk about it here. So Helm likes to say that they're the package manager for Kubernetes applications. In a lot of ways, they are one of the most popular to doing so. I mean, think about your favorite package manager on your computer, like Yum or apt-get or Chocolatey if you're using Windows. Helm is that, but for Kubernetes. Whereas Yum or apt-get, maybe you'd be installing something like curl or wget or whatever. With Helm, instead, you're installing full-blown applications into Kubernetes. And developers love it too, because you can package up their applications using Helm, and now the installation procedure is well understood and repeatable. Helm 3 is tightly integrated into OpenShift. That means you can use OpenShift and Helm to perform tasks like creating your own Helm charts, or modifying existing Helm charts, or packaging and sharing your applications as charts, or searching through a Helm chart repository for applications to install. Again, all from within OpenShift. Okay, so how many of you out there have heard of GitOps? GitOps is the idea that the source of truth is captured in a version control system, typically Git. So not only does it mean you only have to look in one place to see how your infrastructure is configured, but it also means that you can follow the best practices and procedures around a Git workflow. That's things like branching, pull requests, you open up pull requests and Git and code reviews where other team members could chime in and help improve or make comments, so that the best thing you have is fully vetted before committing it and actually making it come to life. So Argo CD is a very popular declarative GitOps continuous delivery. Notice I said delivery, not integration, tool for Kubernetes. Now, it works by watching a particular Git repository for any sorts of changes. So if a change is detected either in the Git repository or maybe in the infrastructure itself, maybe there was an admin that did a one-off configuration change for some reason, Argo CD will figure out what's changed and perform the necessary actions in order to get your cluster back in line with your source of truth. Again, the source of truth is the Git repository. So what does this do? This essentially eliminates configuration drift. Everything that needs to happen needs to go through Git, through the proper Git workflows. And Argo CD ensures that that is what is out there. Okay, and it also works with Helm. So we talked about Helm being able to package the application. You can actually use Helm to deploy your applications using Argo CD. Okay, Argo CD is especially exciting due to the compatibility, that tight compatibility with OpenShift. Since last year, Red Hat has been an important part of the steering committee, helping to guide and nurture this project. But not only is Argo CD easy to install through the Operator Hub, which we'll talk about more in a bit, but it actually soon will become an officially supported tool on OpenShift with integration right inside the developer web console. Okay. So talked about Helm for a bit. Now, I've mentioned the term operators a couple of times. I've tried to make the distinction between human operators, which is a human, obviously, and then operators, which is a technology, a Kubernetes operator. So I wanted to dive into what an operator, a Kubernetes operator was for a bit. Often you might have heard Kubernetes operators come up in the conversation as it relates to Helm. A lot of times they're compared and contrasted, and for good reason. They both perform installations and upgrades. But that's actually where the similarities end. While Helm stops there, operators take it a step further. There's this idea of phases, which is sort of like the capabilities that the extension the tool provides you. So with Helm and operators, you can perform phase 1 and phase 2, which is installation and upgrades, respectively. But phase 3 through 5 is about what do you do after you install, potentially upgrade. You're talking about life cycle, you're talking about collecting metrics, you're talking about intelligence, even the ability for it to manage itself. I love that autopilot kind of idea where it's driving itself. Okay, so in practical terms, think about a database. You simply installing the database engine and upgrading that engine, really isn't enough. You have to migrate and think about that data as well. And this is what operators allow you to do, these complex tasks, along with other things like log analysis, intelligent scaling, and like I said, that auto-tuning idea. So typically these tasks, these complex tasks that I mentioned, like that database upgrade, they typically would be performed manually by a human operator, human IT administrator sitting down and trying to figure out how it goes, or working with the development team and scripting it out, or whatever that solution looks like. But think about all of that information that ultimately ends up in the human operators' heads. So this is where the idea for a Kubernetes operator comes from, where we take that knowledge out of their head and we capture it, we codify it in code, all the workflows, all the procedures, everything around it. Now we can put it in code, have the code automate and do it for you, freeing that human operator to be able to do other things. Okay, so built right into OpenShift is the Operator Hub. It's like a marketplace where you can pull in additional capabilities onto your platform using these operators. For example, let's say you wanted to add messaging or event streaming capabilities. You could pull in something called AMQ Streams, which is the Red Hat supported Kafka project that you could pull in and introduce, the real-time streaming right into your applications that you could start using. And it's super easy to install. If you've ever installed Kafka before, it's kind of a pain in the butt, but with operators, much easier. You click a couple of buttons, configure a couple of things, and you're off and running. Or maybe you wanted to install a Postgres database. Same thing, you look through the Operator Hub, you find your favorite one, click install, and you're ready to go. Again, this allows you to really easily expand the capabilities of the OpenShift platform. By default, you get access to 3 operator data sources. You have fully supported Red Hat built operators like the AMQ Streams thing I mentioned. We have certified operators from ISVs and partners like crunchy data for a Postgres database. And lastly, we have community-built operators, which again, built by the wonderful community. Okay, so I have storage, managing persistent storage, another source of headaches for a human operator. So let's see how OpenShift makes this easier. So first, there are the typical reasons why you would need persistent storage. No surprise here. I mentioned it before, but by default, storage in a container is ephemeral. And when the container goes away, that goes away. So you got to be able to persist it past the life of these containers coming up and going down. So if your applications, for instance, produce files like data like files or something, you'd need persistent storage. Or if you have databases, you need to store it there as well. That's another case for persistent storage. Or maybe you have a bunch of data, big data, where you have to perform a lot of data analytics and AML. Another reason for being able to store, and in this case, massively scale your persistent storage. So what do all of these use cases sort of have in common? Well, there's a couple good factors, important factors that go into a good storage solution. You probably need the ability to scale and grow as your needs increase. You probably need the ability to easily manage that storage solution. You need an easy way to consume that storage. Your applications need to be able to use it easily and quickly. And it really should be cost effective. So OpenShift leverages the Kubernetes persistent volume, the PV framework, to allow administrators to provision persistent storage for a cluster. And then using something called PVCs, which is persistent volume claims, developers can request the PV resources without the knowledge of the underlying storage infrastructure backing it. So OpenShift supports a number and an ever-growing list of storage plugins for various storage solutions. Important note here is that the high availability of the storage solution is left up to the underlying storage provider. And you'll notice here in this picture that one of them is bolded, the OpenShift Container Storage, and for good reason. So the OpenShift Container Storage is a software-defined storage solution. It's highly scalable, multi-cloud portable, and easily integrates with OpenShift. So by scalable, I mean petabytes of data. By multi-cloud, I mean it works with all the public cloud providers and on-prem. And by easily integrates with OpenShift, I mean you can deploy, manage, and monitor your solution all from within OpenShift. The fact that we integrate with AWS, Google, Microsoft, and on-prem solution really speaks to Red Hat's ethos. Like OpenShift can run on these various cloud providers, so too does our storage solution. We want our customers to have the flexibility to be able to choose what's best for them and give them a consistent user experience that's easy to consume and easy to manage. Okay, here are a couple screenshots. This is the installation process. So like most things within OpenShift, it's as easy as going to the operator hub, finding it, and installing it. Maybe a couple configuration bits after that, off and running. Management's easy too. Here we're increasing the capacity made available to OpenShift Container Storage. And lastly, we can see the OpenShift Container Storage dashboard right here within OpenShift. You can get a quick view of all the PVs and all the PVCs, as well as the metrics around that storage. Okay, monitoring and logging. So that's another big component of an operations person's day, in that admin's day. So we've hit upon installation, updates, deployment of applications, storage management. Now, how does OpenShift help with monitoring the actual applications, the metrics and the logs that are running on it? So the OpenShift monitoring solution takes advantage of a few open source projects, namely Prometheus for metrics collection and alerting, as well as Grafana for visualizations. These projects are integrated and come ready for you to go right out of the box. So here's the screenshot of Grafana. I'm sure a lot of you have used it before. A lot of great visualizations and a lot of external plugins you could pull in to really enhance your capability to see what's going on and visualize and slice and dice the data the way you want to. Now logging. OpenShift collects logs from applications using FluentD and ships these over to Elasticsearch, where they are indexed and then visualized using Kibana. Again, all this works out of the box, and you can swap out Elasticsearch if you wanted to for other tooling like Splunk. Okay, now enabling developers. In future sessions, we'll go into more detail about the benefits for developers and along with the pipeline things that I mentioned earlier. But we'll touch on a few of them here today, particularly as it relates to how an admin would set safeguards for the developers and then let them kind of run free and create and have freedom to be able to do what they need to do, but all while doing it safely, all while doing it within the guidelines and restrictions that the operations team has set out, which is critically important. Okay. We've talked about the operator hub a few times, but having administrators set those safeguards in place and allowing developers access to the operator hub means that they themselves can go and pull in those extra capabilities that they need quickly and easily. So no more long waiting times for developers to get the tool that they want, and no more queues of installation requests that a human admin would have to go and work. It's really this idea of self-service. Here's an example of a developer self-provisioning MongoDB as part of their development effort. This self-service idea is a major feature of OpenShift and really drives home the idea of a platform that's both for operations and for developers. Administrators can also configure a standard development environment template. So you no longer need to get a laptop and set up all the various tools and install all these things for them. Instead, you could spin up a container in OpenShift that has all that tooling that they need already pre-installed, as well as that container image being fully vetted and blessed by you and your organization and all of the security policies. So that container that's spun up, you can attach persistent storage so that they can save their work and then, again, let them be productive right away. Gone are those days of waiting for months or weeks, setting up a development environment. Code-ready workspaces takes that and can do it in a fraction amount of time. I'm talking about measuring it in minutes and in hours. Okay, so last, we talk about DevSecOps. That we talked about the ops side, talk about the dev side. Let's talk about the sec side, security. So security is a paramount concern for everyone. If you don't have security, you don't really have anything. It's not as flashy as the other parts of it, but it's, you know, it's super important. It's kind of like eating your vegetables. You know, it's good for you. It's not as fun as eating pizza, but you know, without your veggies, you're not going to be big and strong. So, all right, OpenShift's approach to security is threefold. We have the control, defend, and extend. So we control the bits coming onto the platform. We defend the infrastructure while it's in use, while it's running. And we extend and expand the security shield with tooling from our partners, from our ecosystem of partners. So I'm not going to go into too much detail today because a lot of the security mechanisms in place come in context of pipelines. But so I'll say that the key to a successful pipeline is really having as much of automation as possible, including that security, compliance checks, and reporting. That's all, like I said, an integral part of that pipeline conversation. So outside of the pipeline and the software delivery related task, what does OpenShift provide that enables operations and security teams to work together? Well, one major aspect of security is locking down access to the platform. Role-based access control is a big part of OpenShift. In OpenShift, there are things called projects, which is akin to namespaces in Kubernetes, with either role bindings or cluster role bindings that define the permissions that every user has. So the role component matches attributes on the requests that they're putting in for the cluster. Say they want to get projects, list projects, or create pods. You could put control around what they're able to do. And if no roles match for that particular user, by default, then the request is denied. So locked down by default. And out of the box, we have a couple of roles that are already predefined that you can get up and go quickly, like the user level roles and operator level roles, as well as the ability to create your own roles. So again, to be able to extend it and be able to create the permissions that your security policies dictate. And making sure access is properly configured is, like I said, super, super important. Okay, another important feature in OpenShift is the ability for the cluster to scan itself. using profiles like Essential 8 and CIS to see if the controls on the platform were properly implemented. So Red Hat is aimed to create new profiles on really aggressive timelines in the span of like 6 to 8 weeks or so. There will be more and more profiles that Red Hat is aiming to deliver so that you can increase the amount of checks and scans that the OpenShift cluster is running on itself. And you can even define your own policies and your own profiles if you wanted to. So that way you can really lock it down and really make all of that happen in the way that you need to. So the scans are performed by a tool called OpenSCAT, which is a tool I'm sure you all are very familiar with. And what's really great about this tool is it generates all the reports that you probably need to consume in some way to be able to do compliance reporting. The compliance tool, this thing that I'm talking about here, was a new feature added in OpenShift 4.6. And I really like it because already we've seen out in the field, security and operations team gathering around it and collaborating around it to make sure that the right scans are run, the right reports are generated, and there's this feedback loop going very closely between these two groups, making sure that everything is, is all the I's are dotted, all the T's are crossed. So that collaboration and communication between development, security, and operations really is the spirit behind DevSecOps. And OpenShift provides the tooling and the common platform that enables and enforces this spirit, the spirit of collaboration. So by embracing the DevSecOps in culture, technology, and process, you can use tools like OpenShift that really mean that the fundamental and lasting changes that you want to provide will be able to improve not only today, but for hopefully many years to come. Okay, and that's everything. Hopefully that was informative. Hopefully you got something out of it. Hopefully you had some fun. This is a lunch and learn. Hopefully everybody got pizza and vegetables. Vegetables are important. And that's all I got. Mark, I'm gonna throw it back to you.
Thank you, John. That was incredible. Great amount of information you shared this week, and a lot of enthusiasm. If I didn't know better, I'd say you had an IT operations background. So, John, I don't know if you're aware or not. I know you guys do a lot of work in a lot of different agencies across the federal government, and I know specifically in HHS, OpenShift is being considered and used in different pockets like NIH, but I wasn't sure if you're aware or not. On the VA side, they have implemented something called product line maturity. And so government CIO actually leads an agile transformation project where we provide DevSecOps coaching and auditing for all the products, across VA. And so as a part of that, we're kind of defining the maturity levels. And right now we're at maturity level 1, going to 2, 3, 4, and beyond. So I'm sure you have been aware and have seen this type of thing before. But really, I think what resonates, you kind of talked about some of those benefits of DevSecOps in the beginning, and you're really speaking exactly to the language of what the path that VA is going on right now. I mean, you spoke about a culture of innovation, agility, infrastructure costs. These are all very serious issues that VA is dealing with right now and looking to resolve with modernization, with implementation such as these DevSecOps tools to really bring the dev, the sec, and the ops together. And so really, really great. Let's take a look and see what questions we have with the time remaining. Here's a good one. Looks like we have some folks from VA infrastructure operations joining. So they were asking, so Ansible is currently being used in VA's infrastructure operations for automation. So would like to understand how OpenShift might complement Ansible, and specifically if you could talk about how that might enable getting dev, test, and pre-prod environments all synchronized.
Yeah, great question. Ansible is an absolutely great tool. Real quick aside on Ansible. So Ansible is got a lot of people Red Hat that says, oh, it's so easy, my mother can use it, my grandma can use it. And it is pretty easy. But what I love about Ansible, more than how easy it is really what it allows. It opens up the door to be able to speak the common language we're not thinking about point automation anymore. We're thinking about automation where multiple teams can all collaborate and use the Ansible tool, where now you're speaking the same language, you're all sharing playbooks. It really allows for transformative sort of automation across the entire enterprise among different groups. You think about before, people are writing bash scripts or PowerShell scripts here and there, and yeah, it kind of works here, it kind of works there, it doesn't work there. But with Ansible, it allows everyone to share and collaborate using that same consistent language and do it across the organization. So that's what I really love about Ansible. Now, how does it fit in with OpenShift? Well, OpenShift in a lot of ways has its own automation tooling. And when you introduce the pipeline, there's a lot of automation there. But maybe you're in a modernization effort where maybe you haven't fully migrated everything to OpenShift yet, and you still have very traditional sorts of things. I mean, that's the perfect place where Ansible can still be effective and productive. Or maybe instead of thinking about applications, maybe you're thinking about your network devices. That's another thing that Ansible can automate. So Ansible really, I'm starting with the outside, but there's a lot of things outside of OpenShift that Ansible can help automate and streamline for you, again, providing a consistent language for all of that automation. Now within OpenShift itself, actually Ansible actually plays really nicely because I mentioned that operator framework, that Kubernetes operator that encapsulates like all the stuff in a human operator's brain into code. So that code looks like either Golang code or potentially Ansible, where you don't need to know coding. You can just use Ansible tooling and use the operator framework, first-class citizen, and use that to automate a lot of the functionality that would go on inside of OpenShift. And I talked about those different phases, how phase 5, that highest phase, is that autopiloting sort of thing where it can manage itself. You can achieve that with Ansible. So yeah, Ansible and OpenShift, they go together really well. They complement each other in ways that the other one can't, and they work really great together. Yeah, great. Really good question.
Excellent, excellent. Well, thank you for that. Yeah, I think that certainly will resonate with the developers out there. Synchronized environments, imagine that. So I really liked your reference earlier, tying security to eating your veggies. That's a good one. We'll have to roll with that one. So we got to
do it.
We got a question related to that here. You mentioned security. So especially as it relates to securing the platform, how exactly is OpenShift more secure than Kubernetes?
Yeah, okay, yeah, good question. So security is one of the things that Red Hat is really, really proud of. It's really at the core of what we do. So you think about, first of all, the difference between Kubernetes and OpenShift. You think about a project versus a product. So there's a lot of things that go with that. And one of those things is the process and the engineering behind it. So if you think about Red Hat and the product, you have a team of engineers, you have a well-defined process, and these two are working together and dedicated to finding and fixing vulnerabilities and anything that comes up and making sure everything is working, as opposed to a project, a lot of hardworking individuals from around the world. But if there's a critical bug, what's the SLA? Who's going to jump in and fix that? That looks a lot different. So putting that aside, thinking about the OpenShift platform itself, security comes in layers, right? You lock your door, but you also lock your windows. And you also do these other things that make it harder to breach, to come in and to break in. And so it's the same way with the OpenShift platform. There are levels of security that all work and complement each other. So starting with the operating system, you have SE Linux right there inside of RHEL that work to secure the operating system. And then inside of OpenShift, I talked about the role-based access control to control who can come in. And then we also have FIPS validated cryptography tools that OpenShift runs with to really make sure that we're in compliance. So now I'm talking a bit about compliance, but that's also a critical piece of that, making sure that all the controls and the knobs are properly set to make sure that you're set up for success. And you secure the applications on top. You can also add API management, or even when you think about the applications communicating with each other, you can have a zero trust network, where you have mutual TLS. So you know that the traffic within your own, inside of your service mesh, within your microservices are all secured. there are a number of pieces that all work together towards making the platform secure. Actually, I would invite the viewers out there to go to atopathways.redhatgov.io. Great resource to see a lot of the content that we're producing to help the security hardening, as well as being able to be in compliance so that you can get ATO'd. So yeah.
Great. Thank you for that. Well, actually, I had one more question to kind of add on to that, since we're on the topic of security or eating our veggies. We read in the news this week, looks like Red Hat's going to be acquiring StackRox. I think that's a security, containerization security tool. Can you talk a little bit about that and how that's going to enhance the OpenShift platform?
Yeah, great. This is something we get a lot. So I can't talk too much in detail about the nuances of that relationship because the deal is very close to being finalized. But what I can talk to you about is how great StackRox is. I was super excited when I heard the news about Red Hat acquiring StackRox. StackRox, in a lot of ways, fills in and complements OpenShift with the ability to have, like you said, those security policies defined using a very simple UI. I don't know if you ever use StackRox, but you could sit down and you could define these complex rules right within the StackRox UI. And then you can choose where and when you run them. And then you can choose what to do when those checks, those scans fail. And what's really awesome, I love, is the mentality, that spirit behind it, where there's no automatic remediation, which seems like a bad thing, but actually the remediation is instead a message to developers to educate them to say, hey, this is the way, this is what failed, this is how it should be, and this is what you do to fix it. It's another way to create that kind of that DevSecOps idea where everybody's working together and we're teaching developers how to be secure. I'm a past developer, security, but really is because of not understanding it. But once you work with security teams and operations teams and really understand why you have to do these sorts of things and how to actually go about having it folded into your process on day one, it's not so bad. It's just like, part of something that you do. You brush your teeth every day, you're used to it, not a big deal. Same thing with security. It just becomes folded in and part of the process.
That's great.
So really excited about StackRox.
Absolutely. Sounds like some exciting times over at Red Hat. Looks like we had one here. Let's see, we got a couple more minutes. How does a community and customer organization insert services into OpenShift platform applications such as AI ops, other innovations, and zero trust capabilities?
Awesome. So I'll touch on the zero trust capabilities first, which is we have an offering called Service Mesh, which is the Istio upstream project. But I bring that up because I really love the way that they've done zero trust. So the idea here is that you have a service mesh and you have a lot of these microservices all communicating with each other. And there's a potential for danger there. What if a bad service gets injected or appears somewhere, right? And now you have all this communication going on that could be potentially problematic. So the idea behind zero trust is that there are no trusts between these services. Just because they're communicating and able to communicate doesn't mean that it is valid service. So you have this idea of mutual TLS, which is they have to be able to assert that the other one is indeed who they are and then verify it and then only then are able to communicate. So that idea of zero trust is really powerful and has really become really popular most recently. Yeah, did that answer your question?
Great, excellent. Thanks, John. I think we got time for a couple more. Here we go. Regarding the practice of infrastructure as code, this is really hot right now and something that's looking to be implemented within VA. So regarding the practice of infrastructure as code, are there different considerations for a fully native cloud environment and hybrid cloud environments?
Yeah. So infrastructure as code, the idea of GitOps, I mean, we talked a bit about Argo CD, about OpenShift, but thinking about how all of that works across multiple clouds, I'd say this is one of the strengths of OpenShift, which is even if you're using multiple clouds, multiple public clouds, or you're using private cloud versus public cloud, that management layer, that thing that operators and developers and security people are using day in and day out is the same. It feels the exact same. It works the exact same. and you can't even tell that it's running on whatever your business needs require you to be running on. Maybe one cloud is cheaper, maybe another cloud offers something that the other one, pricing wise or capability or whatever have you. Like, all of that is abstracted away from the people using OpenShift. You're just using OpenShift. So I really love that consistent sort of management plane on top that allows you to have the flexibility of choice underneath the covers.
Excellent, excellent. So I think we got time for one more question, John. How about in multiple OpenShift cluster? How about if I have multiple OpenShift clusters in multiple clouds? How do I manage all of these in the same way?
Oh yeah. So touched a bit on this as well, but you have something we call the advanced cluster management. It's basically a cluster for clusters. So if you have a cluster in AWS and you have one on-prem, well, if you have two separate clusters, it's sort of a pain in the butt to have to log into each of them and then configure them, manage them, apply policies to each. It'd be nicer if there was one place where you could do it, and then it happens into both clusters. And that's exactly what ACM is about. It's that central place that's consistent, again, a consistent feel for an operations person logging in and being able to manage the entire fleet of clusters. In this example, I had two, but you could easily imagine a scenario where you have even more clusters, and being able to define and apply your policies and even deploy your applications all in one place and have it go to whatever cluster you need, or being able to spin up new clusters from within one centralized place. That's really the power of what ACM is providing. Oh, and one more thing, coming soon, we're having more integration with Argo CD and this ACM idea to really bring that GitOps and multi-cloud configuration even further.
Wonderful, wonderful. Thank you, John. That was very, very informative, very timely and applicable to a lot of things going on, especially in the VA. So we are running short on time. However, we did want to offer our viewers the opportunity to continue to ask questions that John or I might be able to answer for you. If there are any other questions, feel free to send those into the newsletter at governmentcio.com. Just say Red Hat, John and Mark, and we will get them addressed and get an answer to you as soon as possible. And as I mentioned in the beginning of the broadcast, this is the second part of a three-part series. Please join us for our next part of the series, 103. That's going to be focused on development, as John mentioned. Here at Government CIO, we are really excited for what the VA is on the verge of. We talk the talk, we walk the walk at Government CIO. We are enabling DevSecOps priorities across the agency. And this series of OpenShift webinars is just the beginning of that. There will be multiple other sessions, information events, information providing events, gathering events, and data that we are going to share to enable and make sure that this is a successful implementation within VA. So thank you for joining this afternoon. We're very excited to bring this information in this series to you. Please do join us for our next series, 103, OpenShift, focused on development. Thank you.